Hi everyone. Good afternoon, guys. Very good afternoon of you. How are you all? Everyone, how are you? So hope you're all doing well. So we'll be continuing our discussions on this SOM quick revision. You can say everyone, right? So what is that SOM quick revision? Right? We have discussed various things in the previous classes now, and we'll be continuing our discussions. You can say, right? All of you. Welcome to Unacademy. Let's crack it, right? Everyone, get ready to crack, all of you. So this is my profile. You can follow me at which, and what is that a referral code you have to use always when you are subscribing to the Plus and Iconic courses. RP Civil is the referral code you have to use. Okay. RP Civil is the code you have to use always. Now these are all GATE 2024 toppers. Those who have secured AR1 from Unacademy. Now here your success chooses the prepared, right? So success will be choosing whom? Those who are prepared, right? Those who are just acting like preparing but not preparing, success will not go to them. Okay, you have to be careful. You can test your GATE preparation with All India Scholarship Test, right? AIST, that All India Scholarship Test will be happening. You can win up to which one is 100% scholarship in your subscription. You can say November 24th the test will be there at 11 a.m. right? You can enroll for this. Those who wanted to have the link of this enrollment link of this All India Scholarship Test, you can just check the description of this video. Okay, all of you can just pause this video and you can check the description of this video, all of you, right? When you are checking the description of this video, you can find the link for this and what is that code you have to use, and everything will be given in that description. Okay. Don't miss this, all of you, everyone. Now so you can win up to which one is 100% scholarship, right? 100% scholarship is possible, right? Don't miss this, everyone. And how much scholarship you will be getting, for what rank you are getting, right? Rank 1 to 3 100% scholarship, rank 4 to 10 90%, 11 to 50 75%, 51 to 200 60% scholarship, and 201 to 500 55% scholarship, and 501 and above 50% scholarship you will be getting, right? So don't miss this, all of you. So here all of you attend this scholarship test, right? Those are already a plus subscriber, right? What you can do is you can just attend this test so that it will be like a practice test for you, right? Those are willing to take the subscription, it will be useful for you, and those who are already taken subscription, it will be useful for you, right? For every people it will be useful, definitely. Okay, right? So these are the crash courses, right? Latestly started on October 11th. So this geotechnical by Amit sir was started. Okay, latest batch has started. You can say, what is that referral code you have to use? Right, RP Civil is the code you have to use. Okay. So here these are recorded plus this live. Some subjects live, some subjects recorded. You can go for. This is Samarth batch for this GATE 2026, GATE and ESC 2026 aspirants, right? On October 25th they have started. Environmental engineering by Jaspal sir, environmental chemistry by KP sir, surveying by Abhishek sir have started, right? Nischay batch for this 2027 aspirants, right? These are the full length batches, you can say. Environmental by Jaspal sir, environmental chemistry by KP sir, and surveying by Abhishek sir has started, right? So depending upon your GATE 2023 and 2024 performance, and depending upon your ESC performance also, you will be getting the scholarships, right? These are all the scholarships you will be getting based on your previous GATE rank. These scholarships you will be getting based on your previous ESC rank, and these are all based on your BTech performance and the college in which you are studying, right, like that. Okay. So these are all the features of this plus subscription you can have. And if you wanted to know the difference between this plus and iconic, these are all the features of this plus subscription. All the features of this plus will be available in iconic. Along with that, these additional features are also available, right? So don't miss this, everyone. Right. So these are all the books, printed books delivered to your home within 15 days of your subscription. Condition is what? If you have taken iconic subscription. Okay. Now coming to this, right, which part we have discussed, right? That is 16 lectures are already over now. Today is which one? 17th lecture we are doing, or not, all of you, right? Today which lecture we are doing, all of you? That's 17th lecture you are doing now. So before we enter into the lecture, check the description of this video, okay? That scholarship test is pinned, right? It is pinned, the link for this scholarship test, and you can go for this, right? Enroll for this and get avail the scholarship of, right? So this is what we have done. Location of this shear center, yes, no? So what is shear center? Before that, expression for this shear stress also we have done. Here, location of this, what is shear center? Location of this shear center we have done. It's an up to 105 points it gets over, right? Now today, the shear center formula for various sections and the shear stress distribution also we'll see, right? With this, the shear stresses gets over, you can say, if you just observe, right? It's not? No. Now, here if you just observe it, what is that, you can say 105 points now. Now we'll be going with 106th point. 106th point will be starting, right? 106th point will be having. So here there are various sections now. Shear center formula for what? Various important sections, okay? So different sections will be covering here. So whenever it is a symmetrical section about both the axes, the CG and this shear center will coincide, as we have discussed in the last class. If you just observe, always it lies on which one? This, always the shear center lies on this symmetrical axis, definitely, na? Always it lies on this symmetrical axis, definitely, you can say, if you just observe, right? Now, first and foremost one, right, what is it? You can say that a channel section. Whenever it is that a channel section, right, how can you have this channel section? If you just observe, this is your channel section, you can say. This is your channel section, you can say. And now what is this axis? If you just observe, this is your symmetrical axis, na? No? And about this axis only that CG will be present, you can say, right? CG will be present, right? Shear center also will be present on this symmetrical axis only, but it will not coincide with the CG, right? Why it will not coincide with this CG? Because it is unsymmetrical with respect to this YY axis, right? Therefore, the shear center will be somewhere outside, right? This is your SC, you can say. Now, from the center of which one, you can say, this web, this is your center of this web, and this is your center of this flanges, na? Bottom flange, that is the center of this top flange, you can say. Now, what are the dimensions you are having, right? From the center of this web to which one? End of this flange, right? This is given as your small b, and what is the total thickness of this flange is given as your TF, if you just observe. And what is the H given from the center of this top flange to the center of this bottom flange, right? That is given as your H, you can say. Like this it is given. Then this distance is taken as your E. What is that E? You can say location of this shear center from this center of this web, na? So what is the value of this E? Anyone having idea? That is your small b square h square TF, right? What is the TF? Thickness of this flange. Divided by this 4 times which one? This IZ. IZ is nothing but your moment of inertia over this ZZ axis, na? This is your ZZ axis. Okay, IZ is nothing but your moment of inertia about the ZZ axis. TF is thickness of flange. B, we know this is a width from this end of this flange to the center of this web, and H, the center of this top flange to the center of this bottom flange, right? TF, thickness of this flange, you can say, is na? Is that clear now? Next, whenever it is at a second one, if you just observe semi-circular wala section. So whenever it is at a semi-circular wala section, if you just observe, so this is your half of this circle only, na? So this is your half of the circle, and what is this axis? If you just observe it, this axis is your symmetrical axis only, no? and your CG will be present at this location if you just observe. Okay, and this is which one? This is center of this circle. No? Now, what is this point O? You can say center of this circle if you just observe, right? That O is nothing but your which one? Center of this circle, you can say. No? And what is that if you just observe it? That is your radius. Na? Radius up to which point? The center of this member only. Na? It is not up to the end. Center of the circle to the midpoint of this thickness. So means from here to here only will be taken as the radius if you just observe, right? Isn't it? Now, what is that E value, right? Your shear center will be present on this ZZ axis only, definitely, right? This is your shear center if you just observe, right? What is the distance of this shear center from the center of this circle? This E will be your shear center, right? What is the E you can say? That is your 4R by this pi if you just observe. That is which one? 4R by what you can say? 4R by this pi you can say. Is not 4R by this pi, right? But do you give guarantee that always semicircular only will come into picture? No, no. No. There might be some circular arc also comes into picture, you can see. Some other angle. So whenever you are considering this is circular arc, circular arc section if you just observe, right? So means is it exactly the half circle, right? No, it need not be the half circle. So this is your axis of symmetry where the CG lies and also the center of this circle lies, both lies. So this is some circular arc we are selecting. Is not? Like this we are having. So this is the point where that center of this circle O lies. Na? This is the point where that center of this circle O lies. You can say if you just observe, right? Isn't it? Now, what is this angle? You can say, right? Let us say this angle is theta. And what is this angle? Right? This angle is also theta. You can say, right? Because we don't know na, at which one it is present. So with respect to the center, the ends of this arc are making an angle 2 theta. You can say. Now, where is the shear center? Your shear center will be present outside. Na? Shear center to the center of this circle, that is small e, you can say, right? What is that small e value given if you just observe? What is that radius, right? Can we select this as a radius, right? Radius up to the midpoint of this thickness, you can say. This is your radius, right? What is this? This is your radius R, you can say. That is your radius, right? What is that E given? This is your 2R into sine theta minus which one? This theta cos theta divided by theta minus sine theta cos theta. If you are substituting that theta equal to 90 degrees, na, then you will be getting this formula. Okay? Theta equal to 90 degrees, if you substitute, right, sine 90, what is that you can say? 1 minus 90 degree pi by 2 radians and cos 90 is 0, na? So no 0. Like that, if you are simplifying, right, you will be getting this previous formula approximately. That is third one. Right? Next, what is that fourth one? You can see if you just observe. Just it is full circle only. Circular. Okay. If you are just considering the circular, where it is circular tube. Okay. Circular tube without a slit. What is the meaning of this without a slit? Right? Completely it is present enough. It's like a pipe section. You can see. We just observe. One second. One second. Let us consider this is your circular tube. Na? Where is that shear center present? Tell me. Where is that shear center present? If you just observe, the shear center is coinciding with what? Tell me. The shear center is coinciding with which one? Tell me. That is CG, right? Why? Because both the axes of symmetry are present now. I told you in the previous class, right? When two axes of symmetry are present, right? CG and this is shear center both will coincide now with a constant thickness. If you just consider this is your CG and this is only that SC, you can say, right? Like that. Now if you consider, right, what is that, you can say, fourth one, this fifth one, if you just consider circular tube only, right? Circular tube means that is your hollow circular, no? Yes or no? Circular tube with a slit, right? What is the meaning of this slit? You can say slit is nothing but your little bit of this opening, no? When you are having a circular here like this, it's a chota bacha opening will be there here. Okay? You cannot even see that opening, right? But there is an opening here. Right? So now whenever this kind of this opening is there, right, what happens, tell me? Whenever you are having this kind of this opening, right, what happens, tell me? We have to identify this axis of this symmetry first, and then first, okay, we'll draw this axis of symmetry here. This is, let us say, the axis of symmetry. If you just observe, just a chota bacha slot is there, but here left side there is no opening you are having. Like this you are having a slot. Right? Now where is that CG present? If you just observe, approximately that CG will be present at this place now. And up to the center of this thickness, right, that is your radius or not? Right? Now where is that shear center present? Shear center will not be inside, right? It will be outside, you can say. That is your shear center. And this itself will be the center of the circle now. So from here to here, right, what is that, you can say, that is your E, right? What is that E value? If you just observe, that E value is nothing but your 2R, okay? Now, so what is that next one? If you just observe, whenever it is at a rectangular section, right? So rectangular tube without a slit. Rectangular tube without a slit, right? Whenever it is at a rectangular tube means that a hollow rectangular, you can say. Without slit means that there is no opening you are having, right? Whenever there is no opening you are having, automatically, right, what happens, tell me? That a CG and this shear center both will coincide, na? Shear center and this CG, right, both will coincide, right? This is your shear center and this itself will be your CG, you can say, right, without a slit. But whenever there is a slit, right, what happens? Rectangular tube with a slit. Whenever there is a rectangular tube with a slit, if you are having, right, first you identify this is your which one, this axis of this symmetry, na? There is a small slot you are having, right? Approximately that CG will be here only. And what is that, you can say, this height, right, from the top thickness center to the bottom thickness center, right, what is that height we are representing? That is represented as this H, similar to that of your channel section only, na? Similar to that of your channel section only, right? This is the center of your, which one, you can say, that web thickness, you can say. This is also the center of this web thickness with a slit, that is without slit. Now where is the shear center? Here shear center will not be inside because it is unsymmetrical with respect to y. Shear center will be outside. Na? For this channel and this kind of sections, right, this is how we are making that shear center location. Na? What is that E look? You can say if you just observe, that is your B into 2H plus this 3B divided by which one? This 2 into H plus 3B. Okay, that is your H you can say. And can we say this is your B? Yes, this is your B, right? From center of left web to center of this right web, that is your B you can say. No? Like that you are having. Seventh one. Eighth one if you just observe. So what is the eighth one you can say if you just observe? That is your diamond section. Diamond with a slit or without a slit if you just observe it, that diamond section without a slit, right? What is it you can say? This is exactly a symmetrical one. Alright, it is not moving below that. One sec. Just let me. Just let me draw this chota bacha diagram here. So what is that happening? Tell me if you just observe it. Because it is symmetrical with respect to x-axis and symmetrical with respect to y-y axis, this is your CG and this itself will be your SC you can say, right? Now what is that? This is your 8th section. 9th one if you just observe. What is that you can say? That is a diamond section, right? What is that if you just observe? Diamond section with slot, with slit, no? Diamond tube, okay? This is not the full diamond, solid diamond, this is a tube, okay? You have to be careful. Tubular section only, no? Now, if you are considering it, this is your axis of this symmetry. So whenever there is a slit, right, so this is your CG will come and SC will be going outside, similar to that of your channel section only. Now, from where we have to consider, right, this is the center of this thickness, na? So for this channel type of sections, always we have to consider from the center. But for a circle type of sections, always we have to consider from which one? This is center of this circle, na? Center of this thickness we have to consider for these kind of sections. This is your E. And what is that E value if you just observe? That is your B by which one? This is 2 root 2. B by which value? 2 root 2, right? What is your B if you just observe? This is your thickness, total thickness. And from this center to that center, right? What is it considered? That is your B, no? From this center to this center, right? What is it considered? That is your B or not? So this is also B only, you can say. So, like that. Next. Whenever it is that I section, if you just observe, right? I section, whenever you are considering, right? What is that I section? You can say if you just observe here. Whenever it is a symmetrical I section, right? Automatically I section symmetrical. For symmetrical I section, right? What is it you can say? It is fully symmetrical about this. Fully symmetrical about this. Both the axis means your shear center and the centroid both will be coinciding absolutely 100%. Is not? This is your which one? Tell me. Center, and this is your center in this direction, centroidal axis. So here CG as well as this SC, right, both will be coinciding here itself, right? Now the last one we'll see, 11th one. I section symmetrical about both, or it is unsymmetrical? It is unsymmetrical about one axis, na? Unsymmetrical about one axis means it may be symmetrical about this other axis if you just observe, right? There is a possibility, okay? Now if you are considering this, so here if you just observe, this is the center of your flange, you can say, right? This is the center of which one? This web, you can say. This is the center of this flange. So always it lies on this one only, no? Now the CG, let us say it lies here, right? And the shear center will be present somewhere here, right? Now from this left hand side, right, what is it considered? That is your E1. And from this right hand side, right, what is it considered? That is your E2, you can say, right? So this thickness will be what? T2. This thickness will be which one? This T1. If both the thickness are same, T1 equal to T2, you substitute, right? And what is this width? You can say B2. And what is this width? B1, okay? And let us say from here to here it is your H. So now if you wanted to write the expression for this, right, E1, right, what is it? You can say E1 equal to T2 into that B2 cube H divided by, what is that? T1 B1 cube plus what is that? T2 B2 cube. T1 B1 cube plus this T2 B2 cube. Then what is that E2? Similarly, if you just observe, E2 is nothing but your everything will be changing a T1 into that B1 cube H divided by, what is it? Same. Denominator is same. T1 B1 cube plus which one? This T2 B2 cube. Okay. Like that we are having which one? This shear center formulae for this various sections. It's over, right? Now coming to this shear stress distribution. Right? This is 106 point now. Now 107 point. So if you consider this is shear stress distribution, for various cross sections, na? For this various cross sections, if you just write for this rectangular, you can directly I'll be writing. So for this rectangular, you can say how it is. It is in this manner, parabolic, you can say. And for this circular also, it will be in which manner? That a parabolic only, you can say. And for this triangular also, right? What is it? You can say if you just observe. This is in this parabolic manner only, right? For triangular also, right? Like that. And for this next, what is another section you can say? This is your diamond wala section. For this diamond section, right? What is it you are having? See actually, if see in this BTech level, actually the basic things only you are having. For this regular sections only, that shear center you will be having, and for this non-regular sections, right, you have to use the concept of which one? This thin plates, right? Theory of elasticity concepts and theory of plates and shells concepts you have to use actually, right? We just cannot get it directly, okay? We just cannot guess directly, right? In that random section also, if at all there is any symmetrical section is there, na? So this point. So shear center does not coincide with the CG in general, except if the section is symmetrical about both axes. Any other section, random section, but if it is symmetrical about both the axes, it is which one? CG. SC always lies on the axis of symmetry. If that section, right, random section, whichever you are selecting is having only one axis of symmetry, on that axis of symmetry it lies, okay? Otherwise, what you can do is you just compare with the nearby which one. So, yeah, whenever these kind of things are there, na, So these members, right, made up of this narrow rectangular more than or equal to two narrow rectangular members now, then the junction of this will be giving the shear center location, right? You can use these three tricks, right? If any of these are valid, you can just select that, right? If these are not valid enough, then you can go with which one? This theory of elasticity concepts and theory of thin shells and theory of shells and plates concepts you have used, right? Those will be studying in this MTech. Okay, with this BTech knowledge you cannot do, right? But generally, mostly you will be having only the questions from these regular sections only, right? So for this diamond section, right, how it is like this will be having. Now, whenever it is an I section, if you just observe, I section and this channel section, because for this channel section also it will be same almost. For this I section and this channel section, right, how it will be if you just observe, it will be like this. So width is higher, shear stress is lesser, right? Here again sudden change, right? Because sudden change in the width is there, na? Here at the center, that width of this web is a chota bacha, small value, and therefore the shear stress will be higher value. You can say like this. Okay? No. Whenever you are going for this plus type, for this plus type of this section, if you just observe, right? So from here to here it is like this, is no? From here to here it is like this, right? But at this place, at the center, that width is very much higher, so therefore the shear stress will be smaller, and it will be having this sudden change like this, no? Because there is a sudden change in the width, right? And throughout this thickness also it will be having this parabolic variation only like this. You are having, no? So no, that parabolic variation only you will be having like this. You can say if you just observe, right? Now suppose if at all this is an I section, one sec, this is your I section only, but what is that you can say, this is how you will be having. Okay, whenever it is an I section, right, if you are having in this manner, right, what is that if you just observe. Okay, one sec, this diagram I'll try to draw it properly. So the width is changing suddenly or the width is changing gradually if you just observe for this I section, right? The width is changing gradually for this I section. So how is that shear stress distribution you will be having, tell me? Whenever it is at shear stress distribution, right, how it will be, tell me? Up to this point, right? Okay. Or you wanted to go with the previous one, I will go with the previous one only, right? Okay. Like this or like that, right? So means generally we don't provide this kind of sections, so okay, no need to draw this kind of section. I'll draw only this one, right, which we are using practically, right? The first one which I have drawn. Okay, now the width will be changing like this, the width will be changing like this here. Now what happens, right, up to this point it is a normal change only, no, normal, that parabolic change only you are having. And from here to here, right, how it will be changing, right? Width is decreasing slowly, that shear stress will be increasing slowly, but how it will be increasing? Gradually it will be increasing, or no, like this, right? Here if you just observe the difference between that I section and this I section, right, what is it you can say? Here sudden change in the width is there, sudden change in the shear stress. Here gradual change in the width is there, that gradual change in the shear stress you are having, right, like that. Okay, so these are all the various sections, right, for which you will be having this shear stress distribution. Got it? Now if you are having this rectangular section also, rectangular hollow section if you are just having, that is box section, how it is? Same, na, same as that of your I section only, na? So no sudden change in the width you are having, sudden change in the shear stress, right? So like this you have same as that of your I section only, no, exactly same as that of your which one, this I section you can have, right? Like that, these are the various cross sections for which this is a shear stress distribution, right? Okay, so next we'll be starting with which one, next class, day after tomorrow will be there. Tomorrow that PYQ session of the surveying I will be doing. Day after tomorrow again we'll be having this, right? In that what we'll be discussing, other topic will be entering into, right? Bending stresses over, shear stresses over, now that a torsion I will be entering into, right? Torsion and springs I will be entering into. Okay, torsion and this springs I will discuss in the next class, right? Just 3-4 classes, this SOM quick revision will be over. Thank you, have a good day. Before you leave the class, right, you just go to the description and that link is pinned for this scholarship test, right? Attend the scholarship test on 24th November, right? Thank you, have a good day.